In the second part now, we're going to take a look at modeling and experimentation, or argumentation. So let's start with modeling. The goal of modeling is a pretty new mechanic for anything we've seen in games. And at a really high level, what we're looking at is a set of behaviors that we've captured for each of the species that we're dealing with, represented on the left. And note, these are not the final visual way of doing it, but just the fastest way to represent a behavior. And what's happening from that is that they are being run over a series of time steps that are creating some sort of simulated model output. And we see that here in the bottom area. And the goal of a modeling challenge is to use existing behaviors that we know and combine them with new behaviors that we don't all the way understand, so that the modeled simulation matches something that was observed. And by doing so, we get at what the kind of definition of modeling is, as far as NGSS is concerned, which is we're building ways to describe some sort of phenomenon as well as predict what will happen. And in that regard, if we just allow the time step to run past where we have existing data, then we would be moving into prediction versus description. So here we've been talking still about this food web ecosystem. We're trying to understand, up until now, we've been talking a lot about the kelp and urchins and how they relate. But here in this model, what we're trying to do is add otters into the mix and say what behaviors of an otter would help us predict what's going on here. At time step 0, everything's fine. But when we move out to time step 1, we're realizing our kelp population is a little too low. And it continues to be low as things go on, and urchin levels are too high. So we're trying to figure out what's going on here. So we've got a couple, behaviors that we get to start with in this interface, and really they are, how much do sea otters eat urchins and how much do they eat kelp? Well, even just looking at this, you think, well, it probably isn't going to help if we have otters also eating kelp because the kelp levels are already too low. But if you do want to play with that, you'll see that, that's exactly what happens. It just makes the effect even worse. So it's probably not that. And if we start playing around with sea otters eating urchins and saying, well, maybe they eat a little bit of urchins, again, qualitative relationships, we see like, oh, that seems to be helping. We still have less kelp and more urchins than we saw simulated. So let's see if sea otters are a little more hungry for urchins. And we see that seems to be helping even more. And if we say that they eat a lot, then we have found a solution where the modeled data, or the modeled version, kind of simulated version, matches the data that we've seen that have been collected from the field. This really is just the first part of how we would use modeling. In the second part of modeling, we would use accepted behaviors, things that we know really work, in order to predict future states. And by doing so, we could play around with, how many otters and urchins would lead to some desired outcome. So that's really modeling, and it's one of the things that we're going to need to iterate on the strongest, in that the mechanic itself feels like it's not very playable yet, and we just need to keep working on it. Okay, so argumentation. This is probably the lightest prototype that we've built, and we've made a couple moves with how to think about argumentation. And the biggest one is that we've decided that the best way to represent argumentation is in actual dialogue. And unlike a lot of games we've seen that try to add kind of like silly card games or other mechanics around argumentation, we really wanted to stick with a pretty straightforward interface, which is that you make a claim, and then through really the interview of the person that you're dealing with, you argue for that claim using evidence that you've captured. Evidence in our game is really limited to the observations you've made, as far as like you've seen certain species interact with other species in certain ways. Potentially you've experimented and come up with specific qualitative or quantitative relationships, or you've built models that have shown that if a behavior from a species has a certain quantitative or qualitative function that it works. So those are the forms of evidence that we're really working with. This is a very simple script, again, very early prototype, just to kind of demonstrate this. So we're at our high level of making a claim, and we've got 2 claims that we've made available right now, and it seems like the otters somehow help the kelp. And if I state that claim, the person we're talking to then says, well, how? And we can move from the observations we've made around behaviors, the ecosystems we've interacted with, or the experiments that we've done. So just using just behaviors, we're able to make a pretty good argument here. So, how do the otters help the kelp? Well, if I say otters don't eat kelp, that's fine, but it doesn't really explain why they help. So let's talk about what evidence we do have. Well, we know that urchins eat kelp. And to link that back up to otters, let's look at one of the otter relationships. Well, we say otters eat urchins. And now we've formed enough of an argument that this one is satisfied. So really, in this mechanic, we're going to be relying on a per challenge dialogue tree that we're going to write that is going to give students the ability to use any evidence they've collected up until now in order to make their point. And it really is going to be on the responsibility of the writers to make this as interesting as possible and dynamic as possible. And that is probably a good place to wrap up. Those are the primary mechanics that we've built, looking at experimentation and observation. And then in this video, we looked at modeling and argumentation. And we plan on iterating for these a little bit, but we, again, really want to make sure that we get these primary mechanics down, that they're going to serve the basis of the interfaces that we'll be able to collect data from while kids are playing. And hopefully this is enough of a demo of that you're able to play with it yourself, and we're able to have some good conversations around how we can make sure this project is going to, provide a basis to do the research we want to do. So let's wrap it up there. I look forward to our conversations.